Hi, my name is Christian with Fun Media. I'm here at the Arkansas Regional in Searcy, Arkansas with Team Breakaway 3937 here on Behind the Bumpers. All right, Tenebeth, why don't you tell me some about the base of your robot this year?
So this year with the base of our robot, the coral was really a difficult thing to work with, and we didn't want it to mess with the electronics in our base. So we designed this plate here out of the Lexan and use the CNC router to cut it out to protect all of our electronics, but it also has a place where you could go to touch the breaker to begin the match. It is also attached with Velcro, so it's easy to take off and put back on throughout. And now I'm going to hand it off to Mark to talk about the elevator.
This year for our overall superstructure, we decided to go with a tilted elevator design, similar to some of the robots that were seen in 2023. We thought that this would give us the most flexibility in terms of our overall strategy. We knew that game piece acquisition would be heavily affected by defense, so we wanted to have the ability to get coral from the ground as well as the station. We also knew that taking that algae off the reef and doing something with it as opposed to just leaving it on the ground would be very important as well. So we wanted to make sure that we would be able to score that in both the barge and the processor. We can demonstrate that we can intake that coral from the ground as well as the algae from the ground. And what's nice about that is that we're able to fulfill a lot of different roles for our alliance. We can be the robot that's a coral specialist and only scoring coral during the match. We can remove algae, be an algae specialist, and we can be a hybrid between all of those things. And of course, we can collapse all of this down to a great height where if we're needed to go to the other side of the field, play some defense, steal some algae, we're going to be great at getting in the opposing alliance's way and still benefiting our alliance partners back on our side of the field. Now I'm going to pass it off to Braden, who's going to tell us a little bit more about the specifics of that turreted intake.
Yeah, so our turret, we decided that we want to be able to intake from the coral station horizontally because that's what we found to be the most effective and consistent way. We were prototyping with funnels and we just found that it was more consistent to do this claw style intake. So we have these 40A Omni wheels that we use to intake the coral from the coral station horizontally. And then from there, we push them against these 3-inch thrifty wheels that then laterally shoot out the coral out the side. That way we don't have to worry about getting our end effector tangled on the reef and accidentally climbing it. We can just shoot it from being above it and not have to worry about any sort of tanglements. And then on the end here, we added this algae fin is what we call it. We use these vector wheels to help center it, and we just pinch it with the Omni wheels for the coral intake and the vector and flex wheels here. You'll notice down here, we actually use PAHT carbon fiber printed with our Bamboo Labs X1C. We've used that for our knuckle block that we use for the wrist, as well as this part that's attached to the gear of the turret. So we really just want to keep the turret as light as possible while still getting a lot of fast functionality. Moving on to the climber, same thing with the architecture. We found the easiest way to package everything was if we would use our elevator itself to climb. So we use these climb wheels. If we go to climb state, we can use the climbers. We center up with the elevator vertical, and then we go just like this. We line up on the deep cage, pushing up against it, and then we line up and we clamp it tight. And then to climb, we just pull our arm back down flat, and that lifts us off the ground, just like that. And now I'm going to pass it on to Jack to talk a little bit more about the programming.
So one thing we really wanted to focus on this year with programming was making sure that the driver could operate the robot very efficiently. So one thing that we were looking at is a very efficient auto aligning system. And so using photon vision this year within Orange Pi, we have one camera here in the belly pan of our robot facing forward so that we can see the tags on the reef. And then we have one camera right here facing backwards so we can see the upward station tags. And so by using those, we can estimate our pose on the field, and then the robot can autonomously drive to line up with each branch of the reef and also with the algae branches. So that way the driver has to focus on where he wants to go instead of actually getting there accurately. And then another thing we wanted to focus on was controlling the coral very effectively. So you can see in our intake here, we have a sensor. It's a can range, and so we can detect when the coral's in the intake, and then also using our wheels right here, we can spin it and then center it exactly where we want it to be. So that way when we score, we know it's in the right spot. So one thing that we had to work on a lot this year as well is making sure that our robot didn't damage itself. As with the turret spinning, it's easy to collide with its own mechanisms. And so using what we like to call the super subsystem, we can control where all of the individual subsystems of the robot are. So the turret and wrist, and then the arm and the elevator. And we can control where they are and check to make sure before we move the turret, the shoulder's up and it's safe so that we don't damage the robot. And I think that's about it for me.
Well, that's awesome, guys. Good luck at this week's regional. Very impressive robot. Look forward to seeing it playing on the field.